Okay, let's look at inverse variation. Today, we've considered the direct variation in our previous class, and in that variation we said it's always written in this form. Let me use a different letter. T varies directly with W, and we said you need to introduce a constant of proportionality to help create a relationship between T and W. So we'll be having T is equal to K W. So this defines the relationship between T and W. But now we're dealing with inverse variation. Inverse variation. In that case, I want you to understand that if you have T varies directly with W, W has a denominator of 1. We can express W as W over 1. Now, for inverse purpose, all you need to do is to change the position of W and 1, where the 1 will be up and W will be down. That defines inverse variation. So we have T varies inversely with W to be written as 1 over W. This is a standard. So if we introduce a constant of proportionality, we have T is equal to K. I like using K. You can use another letter as a constant of proportionality. K times 1 over W. And that will lead us to T is equal to K over W, because 1 times K, or K times 1 is K. So we have this. So this defines the relationship between T and W. Now the problem given to us here is Y is inversely proportional to X, and Y is equal to 4 when X is equal to 1 over 2. We asked to find X when Y is equal to 10. This is one of the JAM questions. So but let's solve it. It's simple. Y is inversely proportional to X. We have Y is inversely proportional to X. This is the expression. Now, if you introduce your constant of proportionality, and I like using K for that, I'll have Y is equal to K over X. This shows the relationship between Y and X. But we can as well make K the subject of the relation. Since they gave us Y and they gave us X, we can use those values to find what K will be to help us write the proper relation between Y and X. So for us to find K, if Y is equal to K over X, remember that Y can also be written as a fractional number Y over 1. Here we cross multiply. So K multiplies when we have K is equal to Y times X will give us YX. So this is the standard for K. We will now use that to solve the first aspect of the problem. They said Y is inversely proportional to X and Y is 4 when X is 1 over 2. So we are looking for K. K will be equal to Y is 4. 4 times X is 1 over 2. 2 we cancel 4. It will be left with 2. So our K is equal to 2. Now we know K to be 2. So our relation between Y and X will now be written as Y is equal to 2 over X. This defines the relation. Should you ask to find the relation between two variables? Relationship between Y and X. This relation or this formula will help us solve the next aspect of the equation. It said find X when Y is equal to 10. Find X when Y is equal to 10. So Y is equal to 10. To find X, write in place of Y, write 10 is equal to 2 over X. 10 is equal to 2 over X. Recall that 10 can be written as a fraction of 10 over 1 is equal to 2 over X. Then cross multiply. X will multiply 10, that will give us 10X is equal to 1 times 2 is 2. Now to find X, we have X is equal to 2 divided by 10. That's dividing both sides by 10. You're going to have 2 over 10. If you reduce it further, then X will be equal to 1 over 5. This is our final result. So inverse variation is simple. If only you understand the standard you need to apply in the course of solving the problem. We're going to have another problem solved in our next other class to help you have a better understanding of this inverse variation. Thank you.